Hello? Is my sound on? Jan, can you hear me? Testing, testing, 1, 2, 3. Hello? Testing. Hello, welcome. Is my audio on? Can everybody hear me? All right. Oh, fantastic. We'll give it just another minute or two, and then we'll get started. I have a lot to go through. Hello, everyone. It's 9 o'clock, and I have welcome to the keynote today, the state of geomapping with Meteor. I have a lot of slides to go through, so I think I'm going to kick the presentation up and kind of get started here. Can everyone see the presentation? The state of Meteor Geomapping, from all tomorrow's parties to COVID-19 reporting with the CDC. Now let's go full screen. All right. Thank you for attending the keynote today. We're going to be talking about geomapping, and there's an old saying in the Meteor community that Meteor makes difficult things easy, and it makes impossible things possible. And we're going to be talking about how to push geomapping in Meteor and what some of the things at the forefront or boundaries of what's possible with Meteor and mapping and real-time data is today, and how that interacts with federal efforts with COVID-19 and some of the activities that have been done using Meteor and COVID reporting with the Centers for Disease Control and Health and Human Services. My name's Abigail Watson. I'm online on the forums as A. Watson 1978, and I've been part of the Meteor community for well over 5 years now. In my real life, as it were, in my professional life, I'm a clinical informaticist. And my degrees and background are actually, I have 2 medical degrees, actually. And JavaScript is just something I've picked up over the years to help in that endeavor. About 5 years ago, I ran into a demo from this company that nobody had heard about called Meteor Development Group. And at the time, in 2015, I came into the Meteor community with around version 0.5. And there were 3 demos at the time. There was a leaderboard, there was the to-dos list, and then there was all tomorrow's parties. And if you haven't ever seen this demo, this was, the demo is still available. You can go to Halahan Meteor Parties on GitHub, you can clone it and run the npm install, and you can still get it today. And you get the Sleaffoot demo. You can do the sign-in, and there's Facebook and Twitter, and there's an account system, and it's interactive. You can click on the map, and it will pop up dialogues, and you can put in your stuff, and it would, real time, it would pop up that icon on the map. And at the time, this was kind of revolutionary. 5 years ago, when we saw this, it was almost as if video games had come into our browser console. And you could put more in, and you could click on the dots, and it would adjust the things on the side, and it was all interactive, a responsive user interface. And to do all of this within the web browser at the time was kind of, it was groundbreaking. And when, and I was sold on it. I was like, I'm in. I want to, this is the kind of web development that I want to do as a healthcare worker, as a clinical informaticist. And it was, but there was some work that needed to be done if it was going to be used by hospitals and healthcare, HIPAA compliance and quality control and these other things. So some of you may know me in terms of this clinical Meteor that we sometimes talk about. And in April 2015, there was we were on version 1.1.3, and I had recently, and that's when I started this clinical Meteor fork or release track. And if you've not been to the website, the idea behind clinical Meteor was we're going to make a release track for the healthcare community. generally designing it like a former technology called MUMPS, which is a very old electronic health record technology that was built on document-oriented databases, similar to Mongo. And so we were taking that model and bringing it to Meteor. In the past 5 years, we've had something like 20 releases. Not a whole lot of people use the release track, but we kind of marched to our drummer and have been having seasonal and yearly releases and kind of keeping track with the whole community. Along the way, we wanted to make some opinionated design decisions around the user interface layer. So we adopted React, but we also took the step forward and added Material UI into it. We also had a scale-out strategy for HIPAA compliance. We wanted to add audit logs in account systems and make sure that it could store data encrypted at rest, encrypted over the wire, these kind of things. I had a call. Okay. We also added quality control to the whole thing. We added a number of packages over the years, and currently the clinical track has something like 200 packages in it, many of which are under quality control, and these are all under running Nightwatch as our quality control infrastructure, and we've been running the clinical track under QA for nearly 5 years now, and we've had 1 million tests go through QA, and so we add that level as part of the clinical track. We also added some card UI and thought about how do we do different size devices, and we did a number of early prototypes. And we're really just kind of interested in the early days about how many different areas could we try to apply this technology. And so we started with the checklist manifesto, we did a medical illustration archive, a personal health record, biometrics dashboard, clinical trials, there was a health planner. We did like 80, we've done 80 projects with this to date. And as we did these projects, these prototypes, we discovered there was a lot of overlapping functionality. And that led us, the overlapping functionality, to a technology which we've spent the better part of the past 3 or 4 years implementing, which is a technology called Fast Healthcare Interoperability Resources, or sometimes called FHIR. And you'll hear me talking about the FHIR resources or FHIR APIs. And FHIR has actually been around for 10 years, and it's a standard that's being developed on how healthcare systems exchange data. And it's so it's sponsored by this company, this organization called Health Level 7. And they're an ANSI accredited standards development group. And they've been developing this API for healthcare. And they're taking a look at what does a patient record look like? What does a condition or a medication or a medical device, when we exchange data about these things, what should those data formats look like? And here we have it in alphabetical order, and there's some 100 different data schemas in this standard or this API. And for each one of these resources, they'll have a page which documents sort of the mission or the meaning of the resource. They'll have examples and mappings and these other things. But the real meat of it are these schemas that they provide. They provide something that's analogous to a JSON schema and which describes the patient. So this is how patient's name should be modeled. This is how, contact, marital status, and race and ethnicity and gender, and they provide the schema. And so this is similar to a Swagger schema, but a little not quite as automated. But they've done the legwork of defining what these data models should look like. And they've gotten the buy-in from the electronic health record vendors, from the federal government, from medical device vendors, insurers, hospitals. They've done the legwork over the past 30 years of getting people on board with these general data models. And they're the over-the-wire equivalent of a database schema. So in the same way that you have a database schema that says this is how the record should look like when it's stored in the database, this does it over the wire as the data is being transferred. Is when you send it over, we ask that you send it in this format. And what that does is that gives us some JSON schemas that we can put in Mongo and Mini Mongo, and it tells us what these records should look like. And it's a huge, huge amount of work off of a developer's plate if you're trying to build healthcare systems, certainly. Also, if you're trying to build systems that in general work with government systems. Many of the federal agencies also use these formats. And one good example is the way that we store the human name. A naive approach to storing a patient record might be to record a first name and last name. But it turns out that there's some cultures that don't store the given name that people use as the first one, but that's not universal. And so the FHIR specification, they've over years just gone back and forth and back and forth, and they've come to the realization that a family and given name is a better model and avoids some of the problems of recording first name, last name. And so FHIR is a lot, the value of it is a lot in the details, in the details of, like, are you recording it in this field or that field, and should there be an array or not? And it answers those questions for developers. I want to take a quick check and make sure that I'm still, yep, okay, so taking a quick check. So this all culminated in a project called MeteorOnFire, which eventually got refactored into another project called NodeOnFire. And NodeOnFire is the latest tech stack that we have built using the clinical Meteor framework. It's still a Meteor application. It still uses Meteor packages behind this screen. You can go to symptomatic/NodeOnFire, clone it, change to the directory Meteor npm install, and then run it with one of the config files in the configs directory, and you'll get a running app. And out of the box, it'll look something like this. We have some screenshots. We give you a nice little blurb when you install it on the home page. It has all the features. You read through it. It includes the kitchen sink. It has kind of everything thrown in. One of the things that we try to do is we try to pull in all of the libraries from Node Package Manager, the NPM repository, that are related to fast healthcare interoperability resources. There's a whole other community outside of the Meteor community, the fire community, and they're developing libraries and publishing them, and we try to pull those in whenever we can and integrate them into the stack. And the stack has all sorts of things. We've upgraded to ES6. We use React and Electron and IPSS, and we use Postman a lot in the framework. We built in Docker. We use Xcode and even a bit of Rollup to build some of our own NPM libraries. Now then, this homepage that will open up when you launch this template actually has a whole sidebar and other pages in it. And so if you open up the sidebar, you can, these are the same as the API items, and we're going to the CRUD, or the create, read, update, delete pages. And here we have a patient table that's empty, but this patient table knows about that patient API and that patient schema. And so if we go in and add, we're going to add a Fire server here as another package. And so we run it with extra packages and have to clone it into the packages directory. But if we do that, we add in the JSON routes package, and we get an API. And so on this base R for patient endpoint, we can get and post those data schemas that were specified by the H07 group. And so if I get this, if I put this into Postman, I can fetch the patient records without using DDP, or the data distribution protocol. And similarly, we can post data directly into the Meteor ecosystem according to one of these API specifications, and then it will land in Mongo, trigger the updates, and then get distributed via DDP. So the model that we're starting to suggest here is RESTful in, data distribution protocol out. And so what this does is it allows us to add Postman to our tool chain. And so Postman becomes a real important part, as much as RoboMongo, as part of our toolkit for building Meteor applications. And if you're going to build a fire-compliant Meteor node application, one of the things that the specification calls for is this metadata route, where and every fire server provides a capability statement. And that capability statement is going to tell you kind of the version of the software, who publishes it, but then it'll also tell you all the different resources it supports. And so it'll say, hey, I'm a fire server, I support the patient API, and you can read, create, update, and delete on me. And with that, you can build healthcare applications that can auto-discover the capabilities of other servers and turn on or turn off functionality. And there's this whole auto-discovery function infrastructure that's in place that's just a game changer in the healthcare world. So we can also post that data, and we post this patient is Peter Chalmers, and you post the patient, and then the server will sort of echo it back with this bundle and say, hey, I received one patient from you. And here's our NodeOnFire application and our patient table, and now Peter Chalmers is in our patient table. And that's all done in a push format, and the responsive, you post the data in, it updates the database signals the client, reactive, or the optimistic UI pulls it in, and it updates, and it's all real time, and there's no refreshing, and awesome. This is a game changer. I want to check in that everybody's following along. All right, it looks like everybody's still online, and we're let's see here. Oops. Okay, back to it. So yeah, grad school. So in 2017, I went back to grad school for a degree in bioinformatics, and I brought some of this technology with me, and I wanted to test it in an academic setting and to get people's feedback. And one of the classes that we had was an epidemiology class. It was healthcare. It was health and geoinformation systems. And I was working on this personalized epidemiology technology, which takes, we have three layers. We have a Google Maps layer. We layer on top of that epidemiology data from the city of Chicago, CDC, other public health data. And then thirdly, we wanted to layer medical history data directly from the electronic health records and pull that in and see where a patient's chart stands in relationship to public health data. And so this was a big interest. So here's an example of it. We're using Google Maps. We've upgraded the Leafly map with Google Maps at this point, and have pulled in municipal neighborhood boundary data. And we also have a list of hospitals that have been coded up in the location API. And so we have those three layers working, the purple lines being the epidemiology or the public health data, and the orange dots being the fire resources being displayed on the map. Here's a similar map. This is, I believe, the Environmental Protection Agency, and this is toxic release. This is buildings and sites in Chicago that have more than 50,000 pounds of steel, or breweries like they have beer chemicals, or newspaper publishing plants. These companies have raw materials that it can leach into the ground or so forth, and so the EPA tracks them. And we have an orange dot of somebody's house. This is the same map, but we've applied a heat map to it. And so you can see this home address is close to a highway that has a lot of EPA tracked locations near it. They're associated with the river that goes through the Chicago River. Here's one from the UK. This is a violent crime proximity showing crime reports. In this, we were testing GPS on a phone, and so this was more of like, can we pull in the phone's GPS and have a traveling beacon? Same thing with drug arrest proximity in the UK. This is a different type of map. This is called a choropleth map, and a choropleth is a bounded region map where you kind of divvy up the surface area into discrete units and you shade it in. And we're tracking Medicare mortality per health service area. And so each health service area is kind of associated with a hospital. And you can see along Appalachia, there are higher mortality, and this was correlated with the opioid epidemic. And so we were doing social determinants, opioid epidemic, and so forth in the class. And so we were making these kinds of maps. Here's outpatient reimbursement per health service area. If you want high reimbursements in your home state, it helps to have an EHR vendor's headquarters located there. Medical reimbursements per enrollee. So you know, we just had all these different kind of maps that we were kind of seeing what we could do with Google Maps and Meteor and these. So this is a different type of map. This was a routing map for like an ambulance or a truck. And so for a short while, I had worked doing a paratransit dispatch project, also on Meteor. And shout out to Justin Berenger and MedStar Cabulance and DART and all the great work that they're doing there. When I got back to grad school, I was continuing looking at this problem of how do you route a wheelchair-accessible van or an ambulance through a half dozen patient homes. So maybe you're picking up today's chemotherapy patients and you have to drive around and pick everybody up. But it's like bus routes. This is a similar map, and we were, I think, using Google Directions with this one. And but this was more of let's go stop by all the different hospitals. And so maybe you're a vendor, and maybe you're servicing MRI scanners and have a truck full of liquid nitrogen and need to stop by all the hospitals to service your do the monthly servicing. Or maybe you're doing a route to pick up soil linens and dispose of biohazardous waste. This is a crime map of Chicago and from the police department, I think, and we're fussing with the icons and kind of giving, can we do a radar graph of the person's location? This is so this is a grocer's map. This is the location of all the groceries in Chicago as of 2013, I think. And so we pulled in the municipal data of where hospital or where grocery markets are located. What's interesting thing about this is you can invert the map and come up with a food desert map. And this was a great map to come up with. We were really excited about this one. And you can see that Lake Michigan, it's a lake and there's no restaurants or no grocery stores. You can't go to the lake and purchase any food. And so it qualifies as a food desert. And this is like a real, this actually has real insights, this map. This one I was kind of excited and proud about. So during grad school, we did all these great kind of experiments and was really kind of looking at how we can push some of this technology. And then nothing. You know what? There was like no interest in this for the next 2 years. I shopped it around and nobody wanted it. They just didn't get why. And until this year, this year, a lot of things changed. COVID-19, and so the national emergency on March 13th was the day when this really took a different direction. And, well, damn, maybe we should update the mapping software and not be looking quite so much at opioid epidemic, but look at COVID-19. So the first thing I did was I started, well, let's make a package. Let's make a Meteor package. We're going to create a COVID-19 on Fire project, and you can go install the software after the presentation. But the first thing that I was doing during those early months of lockdown and the national emergency was we were tracking all of the conditions that were being reported: fever, cough, shortness of breath. We were following the hydroxychloroquine debates, the ventilator shortages. And what I was doing at the time was I was coding all those things up in standard medical terminologies with LOINC and SNOMED, and creating a data mining utility that could connect to the hospital EHR servers and query them and say, give us all of your fever patients, give us all of your ventilator patients. and they come in as these condition or encounter or procedure resources. And with those, we would have the patient reference, and we could do the patient demographic lookup. When we had the patient demographic lookup, then we could start the geocoding pipeline. And eventually we separated out into separate packages because sometimes you want the data mining without the geomapping, or sometimes you want the geomapping without the data mining. But there's a second package that you add that in, and you have to, and the geomapping pipeline will take a collection of these locations, and then we generate a GeoJSON file, which is its own data format. It's loosely JSON. It's a JSON file, but it's specifically around geographical information. And then we would feed it into the Google Maps with some map options and heat map options and so forth. And what you get is your Google Maps. And here are maybe fever patients that have been pulled from the hospital EHR system and might represent where people are feverish with COVID-19 at home in their, you know. So these are COVID-19 parties, at least simulated. And you can scale this up, and you can start adding the heat map in, and you track a bunch of them, and then all of a sudden you're like, oh, like here's an outbreak or not, and you can track all this. This is simulated data, but we were going through the steps of how would we build out a system that would get scaled up for second wave and a bigger pandemic rollout. And then we were also looking at, well, can we do bulk data reporting from the hospital? It's like, can we get the numbers for the hospital and not just do an individual patient number, but also for the whole hospital? Can we do a daily hospital report out? And that brings us to the National Healthcare Safety Network. And this is a U.S. Specific talk. Most of the work I do is U.S. based, although I work with other countries from time to time. But the National Healthcare Safety Network is run by the Centers for Disease Control. And the general idea is that it collects data from all the different hospitals, feeds it to the CDC, which then feeds it on to the Department of Health and Human Services. You would think this would be funded and they'd be using modern technology. Unfortunately, this system is all about uploading CSV files and spreadsheets. And so when the national emergency broke, the CDC sent out a notice or report saying, this is how we want your spreadsheets to be formatted when you send them to us. And it was just where things were at, and it's there were a lot of people dismayed when we saw this. But it was what we had to work with, and it was the systems in place, and this is what the hospitals across the country started to work with. They would put runners out on the floors. They'd say, go count up all of the beds, make a spreadsheet, we'll upload it into this website. And there wasn't any automated querying of the hospital medical record systems. It was just runners and spreadsheets. And they gave instructions on, you know, click on this tab and upload your CSV, and it was what it was. And this is up until, this was how data was collected for the first 3 or 4 months of the pandemic. Meanwhile, there are other stakeholders, municipal governments, the city of Chicago, state of Illinois. There were city and state level and health information exchanges and others who were invested in the process and also wanted this data but they weren't part of the National Healthcare Safety Network. And so so what happened was there just wound up being a lot of emails sent around. So go count up the number of beds, write up a spreadsheet, upload it here, and email this clerk or this deputy at the city and the state. And so a lot of it was being emailed around, and this is a major reason why nobody trusts the numbers. Is there was a lot of hiccups along the way. People would tweak it, fuss it. There wasn't necessarily an audit trail, and it was just kind of spreadsheets and emailing and uploading, and that's been the nature of the pandemic reporting to date, and it's still somewhat that way. Enter a project called SANER, Situational Awareness for Novel Epidemic Response. So at the time of this is all breaking out, this group, HL7 International, which is really one of the foremost premier bioinformatics organizations in the world, they were seeing this, and they started up a project to say, we're going to automate this. And they've been developing this implementation guide on situational awareness of novel epidemic response. And so when the CDC put this data specification out, said, make this spreadsheet for us, HO7 was like, let's not do that. Let's get to those API calls. We need APIs if we're going to get everybody in the nation on the same page. We're going to need these API endpoints, and the EHR vendors are on board, and so they're currently implementing these API endpoints and forklift upgrading all the hospitals to support this. So HO7 had done prior work on what a measure report should look like, and they had figured out gotchas from prior projects about how to model the measures and how to group things, and through past projects, they had encountered enough knowledge, do it this way, not this other way, because you're going to run into, these issues down the road. And when the emergency hit, we had a specification to lean on and to say, well, this works for quality reporting in other areas, so let's use this for COVID-19 reporting and for ventilator stats and other emerging needs. So at the time, we started rolling out user interface for these measure reports, and it started with New Jersey Department of Public Health data because of the New York and New Jersey outbreak. We were pulling in these measure reports, and along the way, we were setting these up and doing a QA credentialing process. And so there's this organization called Meteor, and they're the R&D lab for Medicare and Medicaid. And they put together this test harness to say, let's test the systems that people are building, and to make sure that they query the measures, the locations, the measure reports, and they do it according to the API specification. And so this is the closest thing that we have to a federal credentialing process of are you doing the COVID-19 reporting correctly? So around May, I guess, I was building out a COVID-19 fainer module to participate on this, and then we had this connectathon where we got everybody in the room, the EHR vendors and people from HL7 and bioinformaticists and doctors, and we started doing a data load-in of the New Jersey data, and we get these measure reports, and they can substitute for the data mining. So we get the measure reports in, and then we could pull the organization from it. We could get the location. We geocode the location up, and run it through the geocoding pipeline, integrate the GeoJSON map, and onto. And so this was some simulated data, but this was achieved through this this reporting mechanism that we were interested in. And then those reporting numbers also had metrics. They had counts, the number of ventilators or COVID-19 patients. And we're like, can we, draw our map? Can we get the heat map in based on that vector or that measure? And then it was all going swimmingly. You can adjust the heat map and so forth. This is a different type. This is looking at the national landscape, and it's like, can we get a report from every hospital in the nation? And let's color it in, and it's a coloring exercise. Let's do, that was our first data load in, but then we did a bigger data load in from, we started looking at converting the existing healthcare National Healthcare Safety Network data that they had been uploading with the CSV files, and we wanted to know if we could back enter that data into the new system. And boom! When this map hit, I can't even tell you how. Like, it was a eureka moment. It was, we did it. This is actually aggregated by state, and so each state is reporting in at a state level metric, and then we break that up and copy it to each of the different hospital zones. And so in the future we can swap that out, but details. This is so we're working in these like federal test labs or connectathons, and this is one of the report outs. And here you can see the Centers for Disease Control and National Healthcare Safety Network, and there's symptomatic and Abby Watson right there, and so you can go find, it was official, and we took this Meteor technology all the way to so we're using Meteor technology with the federal R&D labs and the CDC efforts right now. Some of you may be aware that Health and Human Services and the CDC had some, we'll call it, disagreements over the summer where the reporting moved over to HHS. And there's a lot of politics in the background about why that is, but the HHS had another system called Powertracking, and they were doing much of the same thing. And so we then turned and decided to support them also. And we had the ability to make this CoralPlus map and fill it in with different colors. So we went to the HHS website, and they had some opinions on what the coloring should be, and they were like, we want blue and these reds, and we started pulling the HHS data in and creating something of a pandemic travel map of which states are at ICU bed capacity, which ones are not. This is old data. This is from August, and I have to run the numbers again. And so I've been running these numbers not quite on a weekly basis, but close to it. And there's all these metrics coming in now. We have ICU bed capacity, inpatient bed capacity, there's percents and totals, and so in August, Mississippi was just getting slammed, as you look in the lower left-hand corner, and Pennsylvania wasn't reporting for probably nearly a month. They had gotten overwhelmed and weren't able to report out, and so they just went blank. And so this is one of the things that we've been doing with Meteor, is we've been tracing or tracking the CDC and HHS and rendering out basically better maps than what they can provide. We can compile this to mobile. We have this running on mobile devices, and we're preparing a release into the Apple App Store of like a pandemic travel map application that fetches from CDC and Health and Human Services. Once we get it on mobile, we can also do GPS location, and with MiniMongo's near operator, which how many people actually use the near operator in MiniMongo? Few, but what an awesome functionality, and it goes all the way back to that parties demo. That because of that parties demo, we can now do on the client, on mobile devices, we can do that geomapping, but we can do the proximity detection on the mobile device. And we're putting in functionality for finding the closest testing center for you. So when we started working with the HHS, and not just the CDC, Health and Human Services is tracking all the community-based testing sites, and they're doing a lot of it with spreadsheets also. But they've really kind of farmed it out to vendors and partners such as CVS Health, Walgreens, Rite Aid, Walmart. I have to say, CVS Health is doing awesome. This is a map of all the community health testing centers in the U.S. As of August. I have to rerun it. But you can see that CVS has, they have hired something like 120,000 new employees to staff up pharmacies across the nation to provide testing. Followed by this company, I'd never heard of them before, eTrue North from Texas. They have been in every small city rounding and doing COVID-19 response. Kroger's, Rite Aid's, Walgreens, Quest, they're all getting in the game also. And so when we talk about community testing, this is we were able to generate this map using the same technology as all tomorrow's parties, and to see this happen over 5 years, and to see the progress of where it started to how it's impacting the response and being able to play a role. I send these documents to people at the national labs. They've been we're on the radar with the CDC. We're in discussions with contractors to subcontract on and to pick up projects. And it's, I just can't express the gratitude that I have to the Meteor community, to everybody who made this possible, because it actually has helped move the needle in some small part with the things that is happening at the national level. So that pretty much wraps up my talk. Most all of this stuff can be found on our Symptomatic GitHub page. You can go in there, dig in, find much of it is open source, and NodeOnFire, Stack, the COVID-19. I encourage you to take a look at it. We are obviously always in need and looking for help, anybody who's interested in this, please reach out and talk to me afterwards. And just I want to say thank you to the Meteor community for making this possible, because yeah, there's yeah, thank you. And that's it. I guess I can I take questions? We have 10 minutes. Should we wrap up, or are there any questions? Can I turn on the mic, or let's see here. How do I turn on? Okay. Now I have to find polls. Oh, polls. Okay. So questions. So the QA tests for medical craft run nightly, no matter. No, we run the QA tests on commit and pull request. And so we have fits and starts and stops. And so we tend to kind of once a month go through a big round to bring everything back under QA. And so it's not nightly, but it is it's like continuous integration. And so it's on every commit and request. What were your programming experiences before coming to Meteor? I was a .NET programmer, but really I was part of the personal, or like the home computer revolution. And I grew up with computers, like my first computer was an Apple IIgs, and so 1984. So I've been using computers my entire life. So, but I had a whole .NET career doing medical imaging in radiology before coming to the Meteor world. What are you using to generate maps? Google Maps. We use Google Maps for everything, and it's been a workhorse and no complaints. And you have to be careful about prefetching. You have to be careful about online and some of those things. But generally speaking, it's been awesome. And HIPAA compliance. I'm working on medical app myself, and I appreciate that you've been working on strategy to follow the secure patient records. So HIPAA compliance, we have a whole thing on the clinical track about that. You need audit logs. You need accounts. So you have to have an account system. So username and passwords. You need encrypted data at rest. And so we like to use Apple Health Records, and we like to use Mongo because it does the Mongo does encrypted data at rest on the Atlas subscription level. And so you can actually run, so we're of the opinion that you can actually run HIPAA compliant applications on Galaxy if you treat Galaxy as a telco provider, and you really have to have your policies and procedures in place. But generally speaking, yeah, you need accounts, you need audit log, you need encrypted on the wire, encrypted at rest, and policies and procedures. And if anybody wants to reach out, I can send some links and resources on that. Anything else? Any other questions? Okay. Okay, well, with that, I'm going to wrap it up and give people 5 minutes. And once again, I want to thank the Meteor community for making this possible, and thank you for giving me the stage to share some of the work that we've been doing with geomapping and that party's demo, and look how far it's come.